Welcome back, everybody. We are officially on day 5 of Unit 1. So I know this is hard to believe, but we're almost done with Unit 1. You guys have almost made it through your very first unit of living environment, and I'm super proud of you. We're making moves. All right, but before we get started, I do want to say today is one of the very few days, if not the only day, I'm actually going to request that you download this document as a PDF file if you're using a computer. And I'm going to request that so you are able to write on your screen. Since we're doing graphing today, this is pretty tricky to do in Google Docs. So if you have any trouble either downloading this file as a PDF or accessing it as a PDF, please ask either someone in your class or ask me, and I will be happy to give you advice on how to do that. So today's aim is how do scientists display and analyze data? So when we're talking about displaying and analyzing data in science, we're almost always talking about using graphs. So whenever we do an experiment, we are going to use graphs to organize that data so it's easier to read and understand. So by displaying and analyzing data, we're talking about organizing it. So today's do now. Today's do now is actually to show me what you know about graphing. I want you to follow these instructions and fill out this graph on your own. And as soon as you are done with that, press play on this video and we will go over it together. So the very first thing you need to do when you are creating this graph is create a scale on the following 10 by 10 graph. That means that we've got 10 spaces down here and 10 up here. Now, whenever we create a scale, I've got two things I want you to follow. That scale should be consistent. So it should follow the same pattern on your graph. And that scale should be numerical, which means it should be numbers. It should be a number scale. So since we're working with a 10 by 10 graph, and we know that our data values only range between 0 and 7, I'm going to suggest that we just do a scale of 1, which means we're going to have each line represent one number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we're going to do the same thing on both sides. All right, so our scale is numerical and it's consistent, meaning we don't skip numbers. And then this do now asks us to graph the following points. So we're given our x-axis and we're given our y-axis. But first we need to figure out which axis is which. So whenever we're dealing with graphs, our x-axis is going to be down here. And our y-axis is going to be right here. And the way we're going to graph that data is these numbers are attached together. So this is going to equal 1 point on your graph. So for each of these, you're going to go over to the right on the x-axis and up on the y-axis to graph each of these points. So our first one is on point 0, 0, which means we're going to go over 0 spaces on the right and up 0 spaces on the y-axis. So all of that is a fancy way of saying your point is going to be at the very bottom left-hand corner of your graph. Now, the over and right analogy might make a little bit more sense once we move on to this numerical value right here. So since our point is at 3, 2, we're going to go over 3 spaces on the right axis, on the x-axis, and up 2 spaces on the y-axis. So we're going to go 1, use a different color. 1, 2, 3. We're going to go up 2. So that our second dot is right there. All right, and our final point is over 6 spaces on the x-axis and up 7 spaces on the y-axis. So I'm going to count this in red. We're going to go 1, 2, 3, 4, 5, 6 spaces on the x-axis. And then we're going to go up 7 spaces on the y-axis. So 1, 2, 3, 4, 5, 6, 7. So our final dot is going to be right there. Now, something super important that you always need to do for your Regents exam is you need to put a circle around each point and connect those dots. This is the only way to ensure you receive maximum credit on those Regents graphs. So we're going to place a circle, a neat circle around each of our points. And then you're going to connect them using a straight line. So your graph should look something like this on your paper. Now, we also need to label each of the following on our graph. So since we are using these when talking about experiments, we are going to be still using the dependent and independent variable. You can't forget that. Remember, independent is what we are manipulating. And dependent is what you are measuring. All right, and we are always going to find our dependent variable on the y-axis. So this is going to be our dependent variable. Oh, depend. We're always going to find our independent variable on our x-axis. That also means that whenever you see your graph or your data presented in a chart like this, that the first x column right here should be your independent variable, and the y column right here should be your dependent variable. Right? The second thing you need to label is you always should label your x and y axis, which you're lucky we already did. Next, you have to make sure you scale your axis, which we also already did. And the final thing you need to make sure you do is give your graph a title. So since we don't know what data we're working with, our title is going to be kind of vague, but I will give you guys a template that you can almost always follow when creating a title for your graphs. So the template is this. I want you to always put the effect of IV on DV. And of course, whenever you actually have data you're working with, you will replace IV and DV with your independent and dependent variable. But I promise you, if you consistently use the effect of IV and the effect of IV on DV, your graphs will be perfect. All right, let's move on and do an actual practice problem. So this is a Regents exam problem. This has been on a Regents before. So we're working with fish species found at various ocean depths. And we're given that the water depth in meters is the IV, and the number of fish species found is the DV. So the first thing we need to do is scale our axis. Remember, our scale should be numerical and our scale should be consistent. So I want you guys to always start by placing your 0, 0 quadrant right there in the bottom left. And then you need to figure out how to space that scale. So with our x-axis, or water depth, the values we're using range from 50 to 200. So we need to be able to fit at least to 200 on that axis. So let's count this out, okay? Should we do it by fives? So if we count that out, it would be 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. So we can't do it by fives because then our biggest number would be 100. So then how about we do it by tens? So if I count out 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150, we're almost there, 160, 170, 180, 190, 200. Tens will work because we're able to fit all of the the entire range of our values on the bottom of that graph. But now we have to find out a scale for our y-axis. So the range for our values on the y-axis are going to be between 6 and 35. So we have to make sure that we can fit all of those numbers on our scale on the y-axis. Now our scales, I said that our scales need to be consistent, but that doesn't mean that our scales for our x and y-axis have to be the same. So we can use a different scale. We don't have to use 10s on our y-axis. So let's try doing this by, let's try 2s. So if we do 2, 4, 6, 8, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. 2s will work. Let's do 2s. So I'm going to erase those dots I just put and turn those into numbers. All right, so our first line is going to be 2, then 4, 6, 8, then 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. So we have a little bit of extra room on our y-axis, but that's okay, as long as our numbers can fit comfortably on that scale. So now we have our scale, okay? Our axes are already labeled and we already have a title. So the next thing we need to do is graph our data points. So the very first data point we're dealing with is a water depth of 50 meters, and then we have 35 fish species found. So remember, we're going to go over 50 spaces on the x-axis and up 35 spaces on the y. So we're gonna go over 50 and then up 35. So let's go up to 35. Now, you might be wondering, wait, Ms. Collins, but I don't see 35 on our graph. We just have 34 and 36. So whenever that's the case, whenever you can't land perfectly on that number, you're going to aim for the middle. So because we have 34 and 36, we can guess that 35 is going to be right directly in the middle of that point. So you're going to make your dot in the middle of that line. Okay. Next up, we've got over 75 meters and up 31. So we're going to go over here to 70. But wait, our data point's 75. So we're actually going to go in the middle between 70 and 80. And then we're going to go up to 31. Same deal, we only have 30 and 32, so we're gonna go in the middle at 31. All right, next data point, we're gonna go over 100 and up 22. So here's 100, we're gonna go up to 22. That lands perfectly on our scale. Next deal, we're gonna go over 150 and up 13. So find 150 at the bottom and go up to 13. Remember, we don't have 13 on our scale, so we're going to aim for the middle between 12 and 14. And finally, we're gonna go over 200 and up 6. So 200 is our very last point over here. We're gonna go up 6 and land that point right there. But we're not done yet with our graph because we still have 2 more things to do. Remember, this is super important for the regents. You have to connect your dots. Right, so make sure you circle and connect your data points. So I'm gonna place some circles around these. And then you're going to connect them using a straight line. Ooh, that's not very straight. All right, so there we have our completed graph. So now we have a question associated with this graph. The question is asking the approximate number of fish species that can be found at 120 meters is what? So using our graph, we can go to 120 meters that we find on the x-axis, and we can follow that data point directly up to our y-axis. And we see if we follow this trend line that we've created, we can approximate that 18 fish species would be found at 120 meters. So luckily enough, answer choice C says 18 species of fish. So your answer there is C. And we've already completed steps 2 and 3 by plotting the data, marking an appropriate scale, and connecting the points. All right, so you're officially done with part A, graphing practice. Now, you guys have got one more example on your paper, and I want you guys to do this graph on your own, but I'm actually gonna help you set this one up because it requires an additional step that we haven't covered yet. If you are ever asked to create your own data table, if it lists the data points linearly and you have to set it up yourself, you have to set this up in numerical order. So when I say numerical order, set it up according to your independent variable right here. So these values, so here we're talking about hours, should be ranging from lowest value all the way to highest value. And I'll show you what that looks like. So let's go ahead and highlight the hours that we're going to be working with, because that's the first thing we have to sort. We've got 8 hours, 4 hours, 2 hours, 14, 12, 10, and 6. So we want to start with the lowest or the smallest value of hours. So our smallest hour that we're working with here is 2. So the very first value we're going to place in our data table is 2 hours. But we have to make sure that we also attach or write down the attached dependent variable. So here the final height that's attached or associated with 2 hours is 5 centimeters. So we're going to write that down here as well. And now that we have completed, now that we've written in that data point entirely, we can cross it out. So remember, we need to do this in the increasing order. So we're starting with the lowest values and working our way up to the highest values. So after 2, our next biggest value is going to be 4. So we're going to fill in 4 here, hours right here. And we see that 12 centimeters is the value associated with 4 hours. So now we can cross that one out. Right, our next biggest value is going to be 6 hours. And that is associated with 18 centimeters. Cross it out when you're done. Next biggest is 8 hours, which is associated with 25 centimeters. Cross it out when you're done. Next biggest is 10 hours. That is associated with 34 centimeters. Cross it out when you're done. Next up, we've got 12 hours associated with 35 centimeters. And finally, our highest or our largest value is 14 hours. And that is associated with 35 centimeters. So now that we have officially created our data table, I want you guys to complete this graph on your own. So you will need to do a few things. You will need to make a scale on both the X and Y axis. You will need to graph your points. I need to rewrite this, that is ugly. All right, let's write your to-do list down here. So 1, Make your scale. Graph your points. And then 3, circle and connect your dots. All right, so use this data table that we just filled out to complete this graph right here, talking about the effect of light exposure on plant growth. When you are done with that, you have one question to answer about that graph. So the question is, if another plant of the same species had been used in the investigation and exposed to 16 hours of light per day, what would make the final height of the plant? What would the final height of the plant probably have been? Support your answer. So you will need to use your graph to answer this question. All right, when you are done with that, as always, complete your exit ticket. Let me know if you guys have any questions. Graphing can be as soon as possible. Have a wonderful day, and I will see you guys soon.